So this is the first problem on the limiting reactant worksheet. So stoichiometry number 4. The first thing you always have to do in a stoichiometry problem is, of course, balance the equation. So if we look at this, 2 hydrogens in the reactants, 4 hydrogens in the products, 1 carbon in both places, 1 oxygen in both places. So it's relatively easy to just put a 2 right there. It's a 2, I promise. And then we have a balanced equation. And of course, those coefficients are what you use when you want to apply the ratio, what you want over what you have. So the first part of the question asks you to calculate the theoretical yield, so it's the calculated amount of methanol, if 68.5 grams of carbon monoxide reacts with 8.6 grams of hydrogen gas. So this is a little bit different than the problems that you've done before in that they are supplying an amount both for carbon monoxide and for hydrogen gas. So that to you should be a signal that you need to do 2 separate problems. They're the same kind of mole problems that we've done a few times at least, but you need to do 2 of them in order to figure out which of your 2 reagents is the limiting one. So I'm going to set up my 2 problems. In both cases, our end point is going to be methanol, but we need to get there 2 different ways. And I'm going to caution you that you never want to just look at those numbers and assume that you know which one is limiting, because sometimes you'll be right. Today, in this problem, you'd probably be right if you assumed. But there are plenty of problems where, because of the masses and because of the mole ratios, looks can be deceiving, and you can think one thing will be limiting, and in fact, it's not. So, for part A, we are going to start with the carbon monoxide, so 68.5 grams of carbon monoxide, and the molar mass of carbon monoxide is 28 grams. So that'll give us 2 moles of carbon monoxide. Then you need to apply the ratio, the coefficient of what you want over the coefficient of what you have, carbon monoxide. So in this case, it just so happens that it's 1 to 1. So 1 methanol is produced for every 1 carbon monoxide. Now, if you wanted, you could stop there in order to figure out your limiting reagent. I suggest, since you might have to do it anyway, that you carry on and you also include the final step of getting the mass of the methanol. So the molar mass of the CH3OH is 32. And then if you do that math, 68.5 times 32 divided by 28, multiply across the top, divide by the bottom. So then you end up with 78.29 grams of methanol. So that's 1 phase. Now we need to do the same thing with the hydrogen reactant in order to see, of those 2, which one can make less methanol. Because whichever one can make less methanol is going to run out first, right? You're going to have extra of the other thing because it could, in theory, make more. So for A, phase 2, we have our 8.6 grams of hydrogen, H2. 1 mole of H2 is 2 grams, and I'm rounding a little bit. So one thing I just want to point out quick is here I'm using the mass of H2, that I haven't taken into account anything about the coefficient up here. I find for myself, and often for others, that keeping track of the subscripts in the next step of the equation just makes it a little bit easier so as not to get confused. So you could try and simplify those and combine them into a single step, but I don't. But, you know, do whatever works best for you and the way your brain works. That is fine. So we have 1 methanol again, but this time we have 2 H2s. And then, again, you could stop at this point because you'd have moles to compare, but since you're going to have to do it anyway, go ahead and get to grams of methanol. And if you do that, again, multiply across the top, divide by the bottom, so it's 8.6 times 32 divided by 4, effectively. You will wind up with 68.8 grams of methanol. And so this one is your smaller quantity. That means H2 is going to be the limiting reactant. It's going to run out first. The question doesn't ask that, but you need to know that. So it's always the smaller answer that is your correct answer, your choice. And then you just have to think about what the question is asking to know what to do with that information. In the case of this question, in part B, it asks a percent yield. So B, I'm going to change back to the white pencil. So for part B, you have 35.7 grams of methanol actually produced. So that's your actual. And then theoretical is going to be the answer from letter part A. So it's the smaller of the two numbers because that's the one that's going to run out first. We'll run out of hydrogen, and then once you've run out of hydrogen, it doesn't matter that there's more carbon monoxide. You can't do anything with it because you don't have hydrogen. So we'll put this here, 68.8. And then multiply by 100 to get percent, which is usually not a step that I write, but I'll do it here. And so you divide those and you get 51.89% yield.